So we've learned a lot from print rows, but we're not done learning from it yet. Okay, so print rows only prints out, well, 5, right? It only prints out 5 of these things. Doesn't matter how, what I do. If I call print rows over here, it only will print out 1, 2, 3, 4, 5. Okay? Okay, so it's only going to print out 5 stars, right? Because I have a 5 here, right? If I wanted to change it to 10, if I change it to 10, it will do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Does that make sense that I do 10 stars? Because here you've got the values, I is the values 1 through 10. I is 1, so this runs once, then it runs twice, then it runs 3 times, then it runs 4 times, then it runs 5, and so on until it hits 10. Now the annoying thing here is that basically so it puts 1 on the first row, 2 on the second, 3 on the third, and so on and so forth, right? Until we get to then we put 10 on the 10th row. So the annoying thing is that, once I put this over here, it's set in stone. What I would really like is a variable that I can put over here so that every time I call print rows, I could basically on the fly ask how many rows I want to print out. Right? Now I could do that with a scanner, but that's kind of annoying and inelegant actually, because not everything needs a scanner. So instead what we can do is that we can, and this is, now we're hopping back to 4 to talk about parameters and arguments. So first thing is that basically, so the book differentiates between parameters and arguments. I'm going to try to use them consistently, but if you use them interchangeably, that's fine. So we can provide a method with parameters, which says that this method takes in variables. We're just going to deal with one for right now. We can say it takes in an int number of rows. Okay? That means when I call this method, I have to provide it with a single number, which we'll call number of rows. Okay? And now rather than putting, and then I'm going to put this over here, as opposed to it being as opposed to it being just 10, I'm going to put this over here. Now notice over here I have an error now. It says that I've got an error. What is the error? It cannot be replied to, we can't call, it's saying essentially that, well, let's try and run it. Cannot be applied to, it requires an integer, found no arguments. Right? So now I have to provide a number in order to run this method. That makes sense? It says you can use this method if you give me a single integer. Right? I didn't give it a single integer. So how do I give it an integer? Well, I just throw it in the parentheses. So now if I throw 5 into the parentheses, assuming I don't miss, this number of rows that pops up, that's just my ID doing something to help me remember what the variable was. So I'm saying number of rows is now 5. So 1, 2, 3, 4, 5. And now I can change this to 20. And it will print out 20 rows of this. So this is the power of using a parameter, of giving a parameter. Now when I throw something in, 20 is an argument to the method. Okay, so that's like the formal difference. When I call it and use it, it's called an argument. But when I'm defining it, it's a parameter. But I'm pretty much always going to use the word argument. So public static void print rows. Here's the number of rows. 1 through the number of rows. So rather than saying 1 through 10 or 1 through 5, this is just a more abstract thing. This will print the number of rows, right? And we'll print a number of stars there. All right. So now let's go ahead and take a look at doing this in print descending rows. So let's go ahead and look at print descending rows. Right, and I said we'd take a look at this once we got a bit back. So public void print descending rows. It's always going to run the same way for once for right now. I mean, I'm going to keep it at I is equal to 5. I is less than or equal to 1. I minus minus. The first thing I'm going to do just to write is that it's going to run this for loop over here. It's going to say, let's run this for loop. Int I is equal to 0. J is less than I, j plus plus. So it's going to, j's values are going to be 0, 1, 2, 3, 4 in the first iteration. And then when I is 4, it's going to be 0, 1, 2, 3, then 0, 1, 2, then 0, 1, and then 0. So in other words, we're going to have 5 values, then 4 values, then 3 values, then 2 values, then 1 value, right? So we print out 5 stars, then 4 stars, then 3 stars, then 2 stars, then 1 star. But wait, Professor, you might be saying, what about those dashes? Well, for these types of problems, it's always easier if you break them up into parts and look at them as just the parts of what's printing out. Because this will be on not the Pope homework, which you're going to work on shortly, but this homework. And I'm going to be throwing more videos online that cover this specific topic. Okay, the whole printing out these kind of characters, because these are problems I love to give for assignment questions and quiz questions, but not as exam questions. They're pretty. I don't like doing these as exam questions. They're too annoying for exams, and I'd rather have you work on. On exam, I'd actually have you work on something that's kind of fun or useful. All right. So for int I is equal to 5, I is greater than or equal to 1, I minus minus. Okay? So here we printed out 5 stars, then 4, then 3, then 2, then 1. All right. So now what about this line? Well, here we said j is, so let's start, remember, I is equal to 5 at the beginning of this loop, right? So over here, I is equal to 5. So int j is equal to 5. Is 5 greater than 5? No, it is not, so the loop doesn't run on the first one. Now I is 4 on the second line, right? So j is 5. Is 5 greater than 4? Yes, it is. Print out 1 dash. Then subtract. Is 4 greater than 4? No, it's not. So we're done with this, so print out a new line. Okay, now we print out 3 stars, because I is 3. J is equal to 5. Is 5 greater than or equal to 3? Yes, it is. So we print out a dash. Then we print out another dash because 4 is greater than 3. And now 3 is not greater than 3, so we stop. Does it make sense? Then we have 2, so we do 5, 4, 3. 2 is not greater than 2. And then we do 5, 4, 3, 2. And then j is equal to 1. 1 is not greater than 1, so we stop printing it out there. So this is a pretty nice example, I feel. So how can we make this more abstract? To make it, how can we, if we wanted to do int number of rows, what values need to be replaced now in order for this to work? In order for this to be more abstract. So 1. Are you sure? Let's see. Does that seem right? If I want this to print out, so if I want 10 rows, right, I'd put 10 here, right? So let's just think it through. If I want 10 rows, I put 10 here. In I is equal to 5, I is greater than or equal to 10, so it wouldn't run. So we wouldn't want to replace the 1. So if we replace the 5, on the other hand, and we put a 10 there, this would run 10, then 9, then 8, then 7, then 6, then 5, then 4. It would be 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, which is 10 distinct values. So that seems right. And then since we replaced the 5 there, we should probably replace the 5 here as well. So now let's go ahead and run it. Actually, let's not replace that 1 and just see what happens. So print descending rows. Let's start by just doing 5 to show that it still works. 5, 4, 3, 2, 1. So we print out 5 rows. Now let's print out 10. Okay, so print it out 10 stars, then 9, then 8, then 7, then 6, then 5, then 4 stars and a dash, then 3, then 2, then 1. Right? Why? Because 5 was because 5 was not greater than 10, it was not greater than 9, not greater than 8, not greater than 7, not greater than 6, not greater, but then it was greater than 4, so it printed out 1 dash. Then it was greater than 3, so it printed out 2 dashes. Right? So on and so forth. So we replace this with number of rows over there. Then it becomes the more square shape that we were kind of looking at. All right. So our last thing is going to be print word pieces right over here, which will bring us back to the the Blaine Pope homework, which once I'm done with this method, you'll get the chance to work on. Okay, that one doesn't really need, this doesn't need any of the loops that we're doing. You don't need the loops to do this one. Okay, so let's go ahead and work on print word pieces. Okay. So one of the cool things about strings, right, and this will give us an example of basically of printing out 2 arguments. Okay. String word. So here we're taking in so here notice I said we'll print word pieces string word. Rather than taking in a int as an argument, I'm taking in a string as an argument. So let's go ahead and uncomment that out, comment these guys out. Instead, we'll do print word pieces, and I'll pass in the word hello because that's always good. Actually, I'm going to do foobar, which comes from the military acronym, by the way, of FUBAR, which stands for Fouled Up Beyond All Recognition. Only it doesn't, but it's close enough. So let's just show that this works. So we pass in a string, we get the string out. FUBAR. Okay? Now, once we get into, on Thursday, I'm going to go into some subtleties of what happens when we pass variables around, right? Because what happens is that over here, when we passed in a number as a parameter, we copied the number over. And that's what happens with primitives. But with objects, which are more complicated than primitives, we don't exactly create a new copy. We create a copy of the memory reference, which sounds complicated, but basically it says we just tell the computer where to find it in the computer's memory, so that because this string can be anything from just 5 characters to the entire works of William Shakespeare, which is 5 megabytes, and copying 5 megabytes. Copying 32 bits is nothing, but copying 5 megabytes, that's expensive. So instead, we just tell it where to find those 5 megabytes rather than copying over the 5 megabytes itself, which I'll go into detail about more. So system.print line word. So yeah, on Thursday, I'm just going to simply skim through your books and hit all the points that I've glossed over, because that's the way I like to do things. I like to do a 2-pass thing. So once to make sure you get it, and then 2 to make sure you really get it. Okay. So here we do a print word pieces. So we passed foobar in and printed out foobar. Now I'd like to kind of do the same thing that we were doing with the stars, where we printed out star, then star star, then star star star. So I'd like to print F, then FO, then FOO, then FOOB, but we really don't know how to do that yet, right? So In your Blame the Pope assignment, though, I gave you a hint, which is that we've got something called the substring operation. Right, so let's see how that works. So for int I is equal to 0, I is less than, let's go ahead and throw in a second argument just to be fun. Number of rows, because I don't feel like introducing the length operator of rows. So let's go ahead and say 5, right? So exactly the same thing this works out. 1 less than equal to 5, I plus plus, sorry, not 5, number of rows. So if I throw this print line statement in there, right, it's going to print out the word 5 times, right? Right? Passed in foobar and 5, so it printed out foobar 5 times. If I were to pass in foobar and 20, it's going to print out foobar 20 times. Make sense? Right? This is just simply controlling how many times this loop runs. Okay. So now, let's go ahead and take a look at, so I'm back to 5. So let's go ahead and see how we can print out pieces of this. So we've got an operator. So what makes objects different is that you can do dot to access a whole bunch of really cool things in there. So here, dot length, which tells you how big the string is, which we've already talked about. But one of them is substring, which takes in 2 parts, the beginning index and the end index. So let's see what this looks like. 0 to I. So let's see how we've changed this now. F, FO, FOO, FOO, FOOB, FOOBA, right? Still 5 rows. So what does the substring operation do? It's, now remember, right, we're passing in foobar. And the way strings are stored is that they're a bunch of characters. Each individual glyph is has its own special space, right? And we store them in indices that are addressed like this. The first character goes in index 0, the second one goes in index 1, the third, then index 2, then index 3, then index 4, then index 20. No, of course, it's 5, right? So, right, so if I were to say the character at index 3, then that would be B. If I were to say the character at index 4, that would be A. The character at index 1, that's the first O. Right? Make sense to everybody? Okay, so what substring does is that it starts at 0, and it goes up to, so it creates a smaller string, a substring, right, from the original string, a smaller string, that goes up to but does not include the original string. In fact, we get some documentation from Java. Let's see, preferences, adjust font size of these things. See how well that works. Ooh, nice. So it says it returns a string. Oh, come on. Returns a string that is a substring of the string. Let's see. Open as a tool window. There we go. So now we can actually read this. So the substring begins at a specified begin index and ends at end index minus 1. Thus, the length of the substring is end index minus begin index. So, hamburger dot substring 4 to 8 returns the characters 4 up to but not including 8. So it's characters 4, which is 0, 1, 2, 3, 4, 4, 5, 6, 7. So it returns urge, right? It goes 4 up to not including 8, right? Smiles, why not up to and not including? Because that's the default in Java. We go from the first variable up to but not including the second because of for loops. Smiles So from 1 up to but not including character 5, 0, 1, 2, 3, 4, 5 returns mile. Make sense? It's beginning index inclusive, end index exclusive. Now I keep blaming that on for loops, but that's because most for loops, right, are written like this. The start at 0 up to but not including this number. That's the default way of doing for loops, which we'll see in a bit. Okay. Documentation, right, settings. Open this up. There we go. So this was from 0 to 0. From 0 to 1. So go from 0 up, but not including index 1. So 0 to 1, then 0 up to, but not including 2. So FO. 0 up to, but not including 3. So it did 0, 1, and 2. 0, but not including 4. So it did 0, 1, 2, 3. 0, but not including 5. So 0, 1, 2, 3, 4. Make sense? So now, an advantage of this is that if I do, let's see what happens though if I do 10. Oh, so it spats out so fast that basically it got my error interspaced with. So why is my error coming up like this? Well, because my errors and my output fight each other for basically how fast they can print out. So it says an exception, begin 7 at index 0, end at index 7, but you're 6 long. So really you should be going from 0 to 6. Right? So foobar, right? You tried to go to up to index 6, and this doesn't have an index 6. So we need to put an if statement to protect ourselves. So if number of rows is greater than the words dot length, right? If it's bigger than how big the word is, then let's make number of rows equal to, instead of what they put in, word dot length. So that way it's only going to print as many times as there are letters, right? I told it to print 10 times, but it can only print 6, so it only prints 6 now. Right? So with that, I'm going to give you guys the remaining about hour to work on your Blame the Pope program. And I will get to, I'll do more review of these concepts on Thursday.